I'm Craig Stewart. I'm the Campus Bridging Manager for XSEDE, the NSF-funded extreme science and engineering discovery environment. XSEDE supports a large number of very, very large supercomputers that are accessible to the U.S. research community. There are a handful of these supercomputers. There are thousands of clusters spread throughout the United States. If you have a cluster that you're running, or your colleagues are running, or someone on your staff is running, it may well be the case that you're doing a lot of work by hand that can now be automated. XSEDE has produced a set of tools and a set of software that allow you to use automated building software to build a cluster so that it looks very much like the supercomputers in XSEDE, based entirely on open source software, from compilers to application software to job managers. So this can make your work building and running a cluster a lot easier. If you're building one from scratch, that's very, very easy. That's not what most people are doing right now, though. Most people already have a cluster that runs, it works pretty well, and we are just now introducing a new set of tools in what's called a YUM repository that allows you to pick certain pieces of software that are already available as part of the XSEDE cluster build that we're distributing, pick those tools one by one, and install them on your cluster, so your cluster, without wrecking what you've got already, will also work just like the clusters and supercomputers that are in XSEDE. This makes it easier for you to manage. It allows you to reuse training materials that XSEDE has produced. So one of the key concepts in the XSEDE compatible cluster is that commands that work on an XSEDE cluster will also work on your own cluster. Lots of opportunity to make your life easier in managing clusters and in training people to use your clusters. Rich Knepper is going to talk about the details of how to get that software and how to install it.
The XSEDE Campus Bridging team has created the basic XSEDE compatible cluster stack. And what this is a set of software packages that allows a local campus administrator to have an easy installation and management tool for a cluster resource. Maybe a cluster admin has a lot of experience in other areas, but maybe not in high performance. They've been working at the university in IT for some time, and they've been asked to start up a research cluster. This set of packages makes it very easy for them to get started and maintain that. So the first element of that is a ROX role, which is a very simple and very broadly used cluster distribution, which allows an admin to basically put in a CD, it sets up the cluster, they put in our campus bridging role, and that installs the software on the cluster. Mm-hmm. And at the end of that process, they've got a working cluster with all of the packages that we've included. Now, some universities might have a resource that they've already set up, and they don't want to go through the investment of time to reinstall that cluster. In order to satisfy that need, we've created a YUM repository, which is basically just a package repository, and they can access it like they do their regular package management infrastructure. And so all of the packages in the XSEDE software stack are installable, but the admin can pick and choose, and all of the packages end up in a place where they're analogous to what's on the XSEDE resources. These packages include a compiler, so you can compile software that you've written, a parallel library, so that you can run parallel jobs across the cluster, and a scheduler, so that you can create a job submission system and queuing system, as well as a pretty large and ever-growing number of scientific analysis packages. And these packages range from bioinformatics to molecular dynamics, to chemistry, to high-energy physics. The goal of these initiatives is to create a local infrastructure that's very close to what a user would see at the campus infrastructure. So not only does a local cluster administrator get a system that's easy to use and maintain, their users see something that is very similar to what they would see on XSEDE. And when it's time to transition their research to a larger resource, maybe one that's hosted by XSEDE, then all of the tools are in the same place. Furthermore, users can leverage all of the existing training and documentation materials provided by XSEDE. So all of the existing materials that one would find on HPC University, for example, which has lots of tutorials about how to use Linux clusters, how to submit jobs, how to compile and run scientific analysis software. All of those would apply to the basic XSEDE compatible cluster stack that the local campus admin has installed. So by using that, they create a resource that's very similar to some of the resources created with the best practices in the industry, easily scalable to those resources, and leverages existing training and documentation.